Hi, in the last video, I introduced the 2D Pocket Toolpath, and in this video, I just want to kind of expand on it. One of the things that happened in the last video that I did with the toolpath, I had pointed out at the end of the video that what was going on here was that this was not using a Helix entry. So we used a half-inch flat end mill to do this toolpath. So to enter into the material and then the zigzag back and forth to create this pocket. But what I had set up to do was to actually do, and I'll just go ahead and get back into the dialog box here. For the entry motion, I had set up the Helix entry motion. And if the entry attempts fail, so that's one of the selections down here that was just a default, was to just go ahead and plunge into the material. And that's exactly what happened. And the reason that that happened is because that the tool diameter is larger than what we can utilize here inside of this smaller pocket. So in other words, there's not enough room for that tool to actually helix in. And I just want to point out to my classes that, just like I had pointed out in class, that the tool does not actually move in the XY direction here. So the tool is not moving, it's the table that's moving that's causing that helix motion for when the tool enters. But in this case, as I said, it's just not happening. You can see that here just by the trace of the tool path that we're not seeing that helix motion. Something we can do here, and I'm going to do it, I'm going to do a couple different options here for just machining out this simple pocket. One of the things is to go ahead and change the tool. So what I'm going to do first is go ahead and change this to a 1/4 inch flat end mill. And I'm going to keep all the other things the same. So all the other settings, the feed rate, the spindle speed, just everything. I did go in, and I'm not going to redo the search for using the filter and the Mastercam tool library to find this 1/4 inch flat end mill. But on the machine in our lab, the 1/4 inch flat end mill happens to be tool number 3. So I do want to point that out to the students of mine who are watching this. So I'm going to go ahead and select OK. Excuse me. And so what happens now is, just like every other toolpath, if I make changes to the parameters, I end up with this red X that shows up. So in this case, what I'm going to do is I'm going to regenerate this operation. And now you can see on the screen, so this tool that was selected, instead of the 1/2 inch flat end mill, I selected the 1/4 inch flat end mill. And now the tool can actually go into the part using that helix motion. So what I want to do is I want to take a look at the verification of the 1/2 inch flat end mill and the 1/4 inch flat end mill, and then also go back and do a pocket remachining tool path to kind of combine those two. So let's first go back to the 1/2 inch flat end mill. So I'm going to go back in here and select this again, and I'm going to regenerate, and I'm going to run the simulation again. So I'm just going to run it the whole way through, and we can see, just like we did in the last video series, we've got these radiuses here, and of course it's the radius based on the radius of the tool that's chosen. So if I need smaller radiuses in here, obviously the best option is to use a smaller tool. Something I really haven't discussed much in these videos yet is some of the things that you can glean, some of the pieces of information you can glean from the simulation. One of them is a total machining time. So the total machining time for these in the simulation, I've found for these simple parts, is actually relatively accurate. So what this is telling me is that using this 1/2 inch flat end mill and using the feeds and speeds that I'm using, my total time for machining is going to be approximately 1 minute and 38 seconds. Okay, so what I'm going to do now, though, is I want to go in, I want to see what it will do when I use a 1/4 inch flat end mill. So the first thing it's going to do is it's going to make these corner radiuses smaller. So I'll be able to get closer to these sharp corners here. The other thing it probably is going to do is it's going to increase my machining time. So let me go ahead and just get out of here. I want to go back into this parameter and change this to a 1/4 inch flat end mill. And I will go ahead and also regenerate, and you can see what I've got going on here again. You'll see the helix whenever we do the simulation. And you'll also see, and it went pretty fast there. So let me go back and just show you the actual. So that's the start of the helix there. That's what it would look like. And then of course I'm using the depth cut, so it's only going down a third of the way each time. But I'm going to go ahead and play this the whole way through, and you can see in the simulation that indeed, because I'm using a smaller tool, these corners are of a smaller radius, and I'm a lot closer to this this corner here, the sharp corner that's in here. So again, the sharp there's very limited times where a sharp corner is necessary, and there are other machining operations that can be used other than a milling machine to make sharp corners. But it starts to get pricier and pricier. And for the purpose of this class, number one, we don't have those pieces of equipment in the lab, but also it's worth noting that you are, when you're machining, when you're doing CNC machining, that you are always at the mercy of the radius of the tools. In this case, the other thing that I want you to recognize is that I have increased my total time from approximately a minute and I believe it was 37 or 38 seconds all the way up to 4 minutes and 19 seconds. So I'm using a smaller tool, even though I'm using the same feed rate and the same spindle speed, I'm still increasing that total time because it is a smaller tool taking less material out. So that's the trade-off there. Now there's actually another nifty tool within Mastercam that will kind of enable you to get the best of both worlds here, and it's called pocket remachining. So what I'm going to do first is I'm going to go back in here, and I am going to change this back to a 1/2 inch flat end mill, and I will regenerate. And the next thing I'm going to do is I'm actually, well, first let me go back to my top view here. Let me also toggle these toolpath markings off. And what I'm going to do now is actually go in and add an additional pocket toolpath. So I said that there's this thing called pocket remachining, but when you go into the toolpaths, what you're going to notice is there is nothing here called pocket remachining as you're looking at it. So what you're actually doing is just going ahead and adding a second pocket. So I'm going to add this second pocket, and it first asks me to do my chaining again. So in which case I have to chain this whole pocket once again, just as I did for the initial pocket. I should be able to select this this last button here, and that should select the previous chain from the previous operation, and hopefully it does. But in this case, it's telling me that it can't do that. But most of the time, you should be able to do that. So the other option is to just reselect it again, which is only a mouse click away anyway. And be sure that if you're chaining something that's a rectangle like this, or something that is a complete closed chain, make sure that it is indeed that it looks like it is highlighted all the way around the feature or the chain. So and just to kind of reiterate here, I did use this default chaining option to do that. So I did not use the single option as I did back in the contour toolpaths. So I'm going to go ahead and select OK to this, and that launches me into this 2D toolpaths pocket dialog box. So I'm going to choose, in this case, the next size smaller down. So my initial, you can consider this my roughing pocket. In this more finishing pocket, what I'm trying to do is to take out those corners a little better without using the 1/4 inch flat end mill the entire time. And so hopefully, be able to save myself a few minutes of machining time, but still get to closer to where I want to be in terms of, doing an example of rounding out those corners a little closer to the actual sharp corner that's left that is there from the geometry. So in this case, what I'm going to do is I'm going to select this 1/4 inch flat end mill. I'm going to put in a comment here of finished pocket with remachining, and I'm going to change this feed rate to the same feed rate that I used for the 1/2 inch flat end mill. So typically in class, I might slow this down a little bit, but for the purposes of this demonstration, I'm going to go ahead and just make this 20 inches per minute and the spindle speed 2,500, and also change the plunge rate to 20 inches per minute, and also keep this rapid retract enabled. So now I'm going to proceed down to the cut parameters, and this is actually where I now make the change to make this instead of a standard pocket. So right here, and there's a little drop down on the cut parameters page, and I can select the remachining option. So when I select the remachining option, I have some things down here that I have to take a look at and enable or disable as I need. In this case, what I'm going to do is I'm trying to use Mastercam to compute the what stock is remaining from at least the previous operation, or if in case I have more operations than that, all previous operations. So in this case, I only have one operation, and that is sort of my roughing tool. In this case, what I can do here is just keep this radio button enabled in terms of compute the remaining stock from the previous operation. So what Mastercam is going to do is it's going to take a look at what has already been machined out in the previous operation and determine where this additional toolpath has to go to clear out additional stock material to make my finished part. For anything else down here for the clearance, I'm going to go ahead and just leave this as the default. I'm also going to do something here with these options. I'm going to disable this apply entry exit curves to rough passes, because that has to do with things that are going on in the lead in, lead out, which I've disabled anyway, or will disable. What I will add though here is the machine complete finish passes, and make sure that my display stock is enabled as well. So if I don't enable this machine complete finish passes, it's only going to do a finishing pass on the part that it is doing the remachining of. So in this case, it would be just the corners. And you'll see that when we get to the end and actually do start into the simulation. And even before that, when we come to the end of the 2D toolpath. So I'm just going to march down the list here, and you can see in the roughing, I'm not going to actually change anything because I really can't. So it chooses this parallel spiral. I'm going to keep all of the other defaults active. The entry motion is also disabled for this. For finishing, I'm going to keep it the same way that I had the finishing for the original pocket. I'm going to finish this outer boundary, so it's just going to be the outside boundary of the pocket. I'm going to keep the tool down, and I'm going to machine the finish passes only at the final depth and only after roughing all of the pockets. So I'll keep the number of passes and the spacing the same. My lead in, lead out, as I said, I'm just going to keep that disabled. My depth cuts, I'm going to keep that at a max rough step of 0.2. And for my linking parameters, I'm going to go ahead and set this at the same maximum machining depth that I had for the original pocket toolpath, and that's a -0.6. And make sure that all of these are set to absolute. So now I'm going to go ahead and select OK. And when I do that, what you're going to see is something a little different on the screen. And if you pay attention to the screen prompts here in Mastercam, they do a pretty good job of guiding you through what's going on, or what user input it's actually waiting for you to accomplish. So in this case, it's telling me that this is the machine area for the rough tool. So this is where my first tool, my 1/2 inch flat end mill, is going to be machining. Once I hit enter, it's going to show the machine area for the finish tool. So this is what's available to the finishing tool to actually machine. When I hit enter again, it's going to show the remaining stock that tool is actually going to machine out. So I'm going to go ahead and hit enter again, and this is going to show what's going to be remaining after that. So it's not going to get exactly up against the corners there, but I'm going to go ahead and hit enter again so that we can then display that toolpath. And let me go ahead. This is actually the remachining toolpath. So let me change my view to isometric, and you can see what it's doing is it's actually going to the corners. Okay, so this is the first time in this in the series of videos for this class that we've had multiple tool paths inside of one Mastercam program. So what I want to point out to you is that if I go now and I hit the simulation button, notice that I only have a green check mark next to the second tool path. So in order for me to run the simulation and have both of these tool paths run, I actually have to make sure that I have all of the tool paths selected. The easiest way to do that is there's on the very left-hand side here up in this tool paths toolbar, there is this sort of little green triangle with a black arrow. And if you hover over it, it says select all operations. So if I do that, I now can see a little check mark beside both of these folders. So now what I'm going to do is I'm going to go ahead and run the simulation and run all the way through both of these so that you can kind of see what's going to happen here. And I'm just going to run it all the way through. And you can see that I wind up with those smaller radius corners. So it machines out the pocket. I wind up with the smaller radius corners. And now I'm at a total milling time of 2 minutes and 52 seconds. So how does that compare to using either the half-inch flat end mill completely or the quarter-inch flat end mill completely for the tool path? So what happens there is the total time is somewhere in between the two. So just using the half-inch flat end mill but leaving me with bigger corner radiuses was about 1 minute and 37 seconds. Using the quarter-inch, or I think it was 1 minute and 38 in this case, using just the quarter-inch flat end mill was about 4 minutes, 18 or 19 seconds. In this case, I'm using both of the tools. And so I get to take advantage of cutting down on the time with the half-inch flat end mill, but then I also get the advantage of being able to finish out those corners a little better. And I'm roughly in between the two at about 2 minutes and 48 seconds. So hopefully this is helpful to you if you're machining pockets where you want to get a little closer to the corners. And again, how close you get to those corners and exactly how close to those perfect 90-degree corners you get really depends upon the mechanical design and the functional aspects of the design you're pursuing. What you don't want to do is over machine and make something that make a part more costly when it really doesn't need to be. But this is an introductory strategy on how to take advantage of one of the tools in Mastercam to make use of both a larger roughing tool and a smaller finishing tool, and also to be able to cut down on time, but produce more of a finished part of what you might be looking for. Hope you enjoyed the video, and see you in the next video. Thank you.